Okay, so now we have finished the even powers. No, we have finished the odd powers. Now let us talk about integrating trigonometric functions with the even powers. So we talk about even powers. So we just need a prerequisite knowledge about this. We always express these trigonometric functions with even powers in form of double angles. We know it is easy for us to integrate such a number. This is easier than integrating this. This is easier to integrate than this. So if we are given an even power of sine x, we try to put this sine squared x in terms of double angles. How? Look here. So now we know, okay, for me I know, we know that cos 2x is equal to cos squared x minus sine squared x. We know that is true. But we also know that cos squared x is 1 minus sine squared x, then minus sine squared x. So this is 1 minus 2 sine squared x. So it means that when I have, I can make this the subject. This implies that sine squared x is equal to a half into 1 minus cos 2x. Hope that is right. Just take this one, the other one, the other one. Oh, sorry, this is supposed to be 2x. So if we integrate this, this implies that the integral of sine squared x with respect to x is the same as the integral of a half into 1 minus cos 2x dx. And this one is very easy to integrate than this one. So if we follow the same knowledge here and we make cos x the subject by replace, now here I replaced with cos x. So now replace sine squared x in terms of cos x, which is minus 1 minus cos squared x, which is, shall get something like this, 1 plus cos 2x, like that. So that is what we are going to be employing with even powers, and everything is going to be easy for us. For example, I'll give an example. E.g., the integral of sine 4 2x dx. And let me write them. Cos So we have those integrals there, this one and this one. So we start with this one. We express this one in terms of double angles. So we know solution 1. So sine power 4 2x is the same as sine 2x, sine squared 2x, then squared. This is true for this. But you see that if this power was odd, it would be very hard for us to express this one in terms of that. Before I go further this, what if the integral, because we might not see it here, we might meet it somewhere. What if the integral was sine power 6, let's say 2x? I will simply express this one, 2x, then to power, it would be to power 3. It would be to power 3. I know the identity of, so whatever we leave in the brackets, it must have to be to squared. It has to be to squared. It is not a must, but it is the quickest way of arriving to the solution. If you make it to power 4, you shall also need the error. So you will see if you do a lot of examples and many examples, and you know, if you want to pass mathematics, you have to do a lot of practice. Do different examples, try other ways and see. But if you put it in terms of squared, the road will be easy for you to walk along. So now that is finished and explained. So long as you have an even power, make it to power, then the rest will come and you shall just application. So this one is, we know sine squared 2x is the same as, we had our identity that if we have sine squared x is equal to a half into 1 minus cos 2x. So you see when here the angle is 1, here it is double. So it means that sine squared 2x is the same as a half into 1 minus cos 4x. So we have a half into 1 minus cos 4x, but squared. You should not fear the square there. This is we can expand this. So I think I can remove this since I already have this. So now I'm trying to expand this such that I evaluate the integral. So I have, this is the same as a half squared, which is a quarter, into this one squared, 1 minus cos 4x squared. This is a quarter into, when we expand this, we have 1 minus 2 cos 4x plus cos squared 4x, like that. Yes, it is. So this implies that if I have the integral of sine for 2x is equal to the integral of a quarter into 1 minus 2 cos 4x plus cos squared 4x with respect to x. So we can split this integral into the integral of a quarter x minus the integral of a half cos 4x. You know where this half is coming from. Then plus a quarter integral of cos squared 4x. So now we can easily get this. We can also easily get this. But remember also this one is now into, we have to express this one into double angles. So we know that, but cos squared x is equal to a half into 1 plus cos 2x. So whenever we have this one angle, if you have x here, we have double angle here. So it means that when I double the angle here, this angle also is doubled. So it means if I have 4x here, this angle will change to 8x. So I can simply replace this here like that. So now this is the same as the integral of 1 over 4 dx minus a half integral cos 4x plus a quarter times a half, a quarter integral half into 1 plus cos 8x dx, like that. Hope you are together. So this gives me the integral of a quarter dx minus the integral cos 4x dx plus the integral of 1 over 8, this one in brackets, this is 1 over 8 dx, then plus the integral of, this is a quarter times this, of a quarter cos 8x x. So this gives me a quarter x minus, when we integrate this, it is 1 over the derivative of the angle. So it is a half times a quarter, which is 1 over 8 sine 4x. Remember, when we integrate cos x, we get sine x. Then plus 1 over 8x. Then plus, this is 1 over 8 times 1 over 4. So it is 1 over 4 times 1 over 8. 8 times 4 is 32. 1 over 32 sine 8x plus the constant of integration. So you can go ahead and add this one and this one, a quarter plus 1 over 8, and solve to the last step. So when you are dealing with even powers, the trick is just expressing, knowing the equivalence of the sine squared x in terms of double angles, as we have talked about later on in the video, and even cos x the same, talking about it in terms of double angles. So whenever you're given an integral, a trigonometric integral, so first look at the power. If it is an odd power, you follow the steps that we have talked about in the previous video. If it is an even power, you simply follow the steps that I have talked about, and everything will be easy for you. So thank you for watching, and make sure you subscribe to my YouTube channel such that you get all the notifications when I upload these videos, and I hope they will be of use to you. Bye bye. So next time when we come back, we shall talk about quadratic factors. Quadratic factors integration. Still, it will be under trigonometric functions in terms of quadratic factors. Thank you. Bye bye.